Hi friends, welcome to Physics Coach. मेरा नाम अंकित. So in this lecture you will understand the moving pulley numerical. So first numerical is write down. In this numerical we will understand how to find the acceleration of blocks when pulley is moving. For example, this pulley is moving with velocity. It may be acceleration, it may be velocity, it may be displacement. For example, this velocity or acceleration you can take 5 meter per second square of this moving pulley. So on this pulley there is one string is here like this and one string is like this. I have attached two blocks like this, one block and second block. I don't know what is the mass. For example, this mass is 2 kg and this mass is 3 kg. Is it clear? Now I just want to know what is the acceleration of these two masses. For example, acceleration of this mass is A1, acceleration of this mass is A2. Is it clear? Since the pulley is moving, we can't apply the visible constant relation. So acceleration of pulley, we know what is the relation. Acceleration of pulley is equal to A1 plus A2 by 2. Now what is A1? A1 is the acceleration of end point of the string. A1 is the acceleration of end point of the string. So how in what a- acceleration is rate of change of velocity. So at what rate this end is moving up or down, wherever is it moving, it will come automatically. But A1 and A2 are the acceleration of the end of the string. Clear? Now we will decide the frame of reference. This is my observer. I have decided this is my x, this is my y. Is it clear? Now, according to this observer, this pulley is moving up. For example, the acceleration A1 value is this 2 kg block is moving up with 1 meter per second square acceleration. So I just want to know at what acceleration this 3 kg block will move. If this end will move, this 3 kg block will also move. So A1 acceleration is up. Up means according to this frame of reference, up means positive. Positive means plus 1. I want to know what is the acceleration of A2. So A2 will comes out to be 5 to the 10, 10 minus 1, 9 meter per second square. So this is the acceleration with which this 3 kg block will move up. Positive, it is coming positive. Positive means according to our frame of reference, it is going along positive y-axis. Is it clear? Now moving to the next problem. This is another question. Write down. This is a pulley and this is a string and this end of the string is fixed. And here is one block. This is one block and this block is, I want to know what is the acceleration of this. This pulley is moving with 2 meter per second square acceleration. So I just want to know what is the acceleration of this block. The block mass you can take 3 kg. Clear? So I just want to know what is the acceleration. Simply apply the relation. If the pulley is moving, for moving pulley, acceleration of pulley equal A1 plus A2 by 2. This is the formula we will use. So what is the acceleration of pulley? It is going up. So to A1. A1 is the acceleration of this end of the string. This end is fixed. So this is 0 plus A2. A2 by 2. So A2 comes out to be how much? 4 meter per second square. Is it clear? So 4 meter plus 4 means this 3 kg block is moving with how much acceleration? Plus 4. Is it clear? I think up to this, any doubt to anyone, you can ask me. Meanwhile, I am rub this. So any doubt to anyone? Now moving to the next problem, write down the next question. Write down the draw the figure. This is a one pulley that is fixed, and this is one block. One block is moving with how much acceleration? 2 meter per second square. Now there is one more pulley like this, one string, and here two blocks. One block here, one block is here. We don't know what is the mass. I just want to know. My question is this is moving down with 3 meter per second square. Then what is the acceleration of this? This block. What is the acceleration of this block? For this block, what is the acceleration. So simplify the relation which I just told you, AP equal A1 plus A2 by 2. It is valid for one pulley, one string, and two block like this. That relation is valid for not fixed pulley. It is for moving pulley, but there is one string, two block. So that relation is valid for this condition. Pulley is moving, and that relation is valid for that. Clear? Up to this, any doubt? So likewise, we will here at this end, for example, see only this pulley and one string. Can you see this is one string? One string. So see the end of the string. This end of the string is connected with this block, and this end is connected with the this pulley. Is it clear? Now don't see the bottom portion. See only this and this. So I will calculate first the acceleration of this. I will apply the simple relation is AP equal A1 plus A2 by 2. Is it clear? Now acceleration of this pulley. This pulley is movable or fixed? Fixed. So acceleration of this pulley is 0. A1. A1 is the acceleration of this end of the string. It is moving up. Means positive. A2. A2 will be divided by 2. What is A2? How much? A2 comes out to be minus 2. Minus 2 meter per second square. Minus is indicating that this pulley, this is a pulley which is connected with this end. It is moving down with which acceleration? 2 meter per second square. So minus is indicating means downward motion, because as per our frame of reference, up is positive, down is negative, right is positive, left is negative. Now we will apply, I want to know the acceleration of this block. Simply I will again apply this formula for this. Can you see? Now I will apply the formula for this. Now I apply again the same formula for this moving pulley. AP equal A1 plus A2 by 2. So see here, AP is how much? Acceleration of this pulley, it is going down. So you will take with sign minus 2 into 2 equal A1. This is going down. So minus 3. Then how much A2? Calculate. What is the answer? Tell me. What is the answer? Finally, you are getting how much? A2 comes out to be, please solve, how much? Tell me the answer. Minus 4 plus 3, it is comes out to be minus 1 meter square. So minus is indicating what? This block. This block is moving in which direction? Downward direction. Is it clear? I think this question is clear. So AP equal A1 plus A2 is a very important relation, and it can solve many problems. For if pulley is not fixed, then only you will use the same concept. Now again, I am giving you one more question. You please try the same question, but here string is like this. This is the string passing through this pulley. Clear? Like this. And one block is here. Maybe my writing is not good, but don't see my writing, only see the concept. Here this is this end. This end is fixed. Clear? Now I just want to know what is the, this is like that. Numerical is given. This pulley is moving with acceleration 1 meter per second square. Now I want to know what is the acceleration of 3 kg block. Simple. Pulley is moving, draw the frame of reference. We have drawn, this is x, positive I. Clear? Now we will apply, since pulley is moving, one pulley, one string, and A1 and A2 are the acceleration of end point of the string. So these are the end point of the string. Is it clear? So any doubt to anyone? Now we will apply the simple relation AP equal A1 plus A2 by 2. Put all the values with sign. This pulley is moving in right. Right means according to our frame of reference, positive. So here plus 1 equal A1. A1 is the acceleration of end point of the string. You can take this A1. This is 1. This is 2. So this end is fixed. So this is 0 plus. A2 is how much? A2 is coming out to be plus 2 meter per second square. So this end, this block, 3 kg block is moving, plus 2 means it is moving with which acceleration? 2 meter per second square in the right. Is it clear? So these are the questions. We will solve one more question. Write down. Write down the numerical. One more numerical, easy one. I will give you. You all will solve. Clear? Now write down the question. This question is little bit for you tough, but it is very easy question. This is a pulley. Clear? And this is, there is one more pulley like this. This is string and it is fixed. Now this pulley is attached with one block, and here one block is here on this inclined plane. This is attached with a string like this, and we are giving the acceleration for this block 4 meter per second square. Clear? Now tell me how to solve this. What is the answer? I want to know what is the acceleration of this block. What is the acceleration of this block? Now tell me the answer. What is the answer? Give me the answer. Tell me. Simple. Now see, if this block is moving up with 4 meter per second square, so this string will also go down with 4 meter per second square down. So this end of the string, if this block is moving up with 4 meter per second square, then this end of the string will go down. This end is fixed. So this acceleration of this end of the string is 0. Acceleration of this end is minus 4. Acceleration of this end is 0. Divide by 2. Acceleration of the pulley will be how much? Minus 2. Minus 2 meter per second square means this pulley is moving down with 2 meter per second square. Minus means it is going down. It is going down. So if this pulley is going down with 2 meter per second square, so this block will also move with 2 meter per second square because it is connected mass system. Clear? So here this is, let me rub this. This comes out to be how much? Acceleration of pulley comes out to be here minus 2 meter per second square. Minus is indicating it is going down. So simply this is block is moving up with 4 meter per second square. So this end, can you see, this end will going down with 4 meter per second square down. So we got the acceleration of end of the string. Clear? When it is going up, this end will go down. So finally we are getting the answer because this relation is valid for one pulley, one string. Can you see? One string, one pulley, and this pulley must be moving. Here pulley is moving. So this relation AP equal A1 plus A2 has so many application. Always put the values with answer. What is A1? A1 is the acceleration of endpoint of the string. What is A2? A2 is the acceleration of endpoint of the string. AP is the acceleration of moving pulley. So thanks once again. Thank you so much. In the next lecture, we will understand when inertial frame and non-inertial frame, pseudo force, how to apply the pseudo force. We will solve numerical. So thank you so much. Thanks a lot.